Okay. We already learned how to make the tree and set the tree parameter into the tree viewer. So we can have another point of view for the tree by looking at the performance. So the tree, we can check the test and score. Test and score means we can check the accuracy. How to check the accuracy? First, we need to give the data into the test and score, and then with the tree, we are going to see the performance. Now you can see here in the left part, there are several things you can use. For example, the cross validation or random sampling, leave one out, and you can test on the train data and you can test on the test data. So let's use the cross validation. When we use the cross validation, you can see we have some measures here. CA. CA is the classification accuracy. F1. It is the F1 measures that you already learned in the PowerPoint. Precision and recall. So the CA or the accuracy is very low. But yeah, you can check later how can we improve this one. The number of folds, you have 5. So if you click this one, you can see there are several other numbers. Like you can set the number of folds 2 or 3 or 10 or 20. So the default usually 5. The most common fold is 5. You can see the accuracy is 0.35. Now let's figure out if I use the random sampling. If I use random sampling, I would like to repeat the train or test for 10 times, and the training set is 66%. And we have the stratify. Do you know what is stratify? Stratify. Stratify sampling. If you still remember, in the sampling section, we learned the stratify sampling. It is a sampling that consider the label. Okay. So if you have the label or you have the categorical value attribute used for the target, then each of the target will be sampled equally. So we have the stratified sampling here, and then for every of the target, we will make the equal distribution. So with the random sampling, okay, we can see the classification accuracy improve to 60%. And if I'm using the leave one out, let's say if I use leave one out, okay, the classification accuracy is improving again, 70%. Then, from the partitioning approach that we learned before, the cross validation, the leave one out, it will avoid the overfitting. So maybe this way is a better way to create your model. And after you have this test and score, you will be able to create the confusion matrix. In the confusion matrix, as you might know, we have the actual and you also have the predicted result. If it is yes in the actual data, so I want to know what how many it is yes in the prediction result. In this case, I know that okay, the value is 7 if the actual is yes and the predicted is yes. And I want to know what is the number when the actual is no and the predicted result is no. So we have 3 in this case. Then the accuracy will be 7 plus 3 divided by 14. So 10 divided by 14. So you will check the the accuracy is 71%. Let's say I want to see this result is the misclassified or this is the not correct classification. This is also not correct classification. Okay. Then I would like to use this data and this data, and then I want to check the data. So I want to know what is the problem. The actual data, the person bought computer, but from the decision tree, it gave didn't buy computer. So the prediction result is different with the actual. So you can check, okay, maybe because this is the person above 40. So it is difficult to classify in the correct answer. Okay, so you can look at that kind of details. Yeah, in your team project, you need to understand the tree. You need to understand all the things like what I explained to you about the confusion matrix. And then you need to find some kind of patterns. Let's say if it is misclassified, then what is the problem? What is the pattern and etc. So I would like to make you more clear about the classification. When you do the classification, now you can see the data already logged with columns. But now let's start with the small column first. We know that we have the customer data, and the customer data is we have 14 data. Okay? And let's suppose I just limit the column into age and bias computer. I just know the age column, which is whether the person is less than 30 or 31 to 40, higher than 40. And I want to check whether the person is buying computer or not. With only one attribute, with this target, we can see the 9 among 14 data is buying computer, and age is the most important attribute because there's only one attribute, which is age. If you remove this binary, okay, if you remove the binary tree, then you will see it's of this category. So the first category is 31 under 40. The second category is minus less than 30, and then the third category is higher than 40. So you can see if it is perfectly shown 100%, the color is red. But if it is still somehow 50-50 or 60-40, the color is more light. So here the color is lighter. maybe if it is no, then the color will be blue. And if it is yes, the color becomes red like this one. But if it is pink like this, so we still need to split again. So for example, this one is already 100%, but this one is still 60, and this one also 60. So in order to make a good classification, we can determine what will be the best next attribute. So for example, now I have student attribute. So I can use this student attribute and then put it into this tree. The additional attribute increase the tree complexity. So if you have more attributes, of course, the tree will be more complex. It becomes more difficult to understand sometimes. So in this case, because I know that this already 100%, so we cannot split anymore. This one 60%, we can split more. And the most important attribute is student, because we have the additional attribute which is student. And the student is no, then the result is also not buying computer. And you can see this is already 100%. If it is already 100%, then you don't need to split anymore. If the student is yes, okay, then okay, most of them for computer 100%. So the color now becomes red. If it is higher than 40, when you split according to the student, because we only have the attribute student here, then it's still 50% and it is still 66.7%. Actually, we can split more, but if we have the parameter, this is only 2, and this is already 3 or less than 5. So we cannot split more. And this is the final decision tree when we have 2 attributes, age, student, and 1 target class computer. What about this one? I put one more attribute, which is income. But if you look at the tree, the attribute that split here is student, and the attribute that split here is still student. So where is the attribute income? So the additional column does not affect the model. So when you calculate with the Gini index, when you calculate with the information gain or with the gain ratio, you can see that it does not affect the model. So that's why there is no attribute included in the tree. So the attribute is still student. And let's say now I have a complete picture about the data. So we have this final attribute, which is the credit rating. And then the decision tree has been updated with the new attribute. You can see that when the age is less than 30, we have an attribute student to split into no and yes, and it is perfectly split. It is perfectly split. What about this? When it is split with the credit rating, so it means when you calculate with the Gini index, when you calculate with the information gain, with the gain ratio, then the credit rating is the highest. Or this is the most important attribute to split. So we can get the no when the credit rating is excellent, and we can get yes when the credit rating is fair. So this is 100% and this is 100%. And we can say that this is the best decision tree because every of the data can be split into the particular label. When you do the team project, I think you will never get this solution because this is the best solution. So you need to figure out what is the meaning with your decision tree if you use the decision tree later. Now let's see with one example in the real world practice, we have the data auto MPG. I give you the data set. I give you this file. Okay, if you look at the e-class, there is OWS. This file is the orange worksheet. Okay, so you can open this classification. So in my case, I use this one. Okay, let me open it. So this problem, we will use the dataset widget. If you still remember the dataset widget, you can see a lot of dataset provided by Orange. So now we're going to use the auto MPG dataset. What is auto MPG? Auto means okay. MPG. What is MPG? So you can look at the detail of this dataset. This dataset is slightly modified version of the dataset provided by the statlib library, in line with the use by Ross Quinlan in predicting the attribute MPG. So the attribute MPG will be the target. 8 of the original instances were removed because they had unknown values for the MPG attributes. The data concern city cycle fuel consumption in miles per gallon. So MPG means miles per gallon. It will be predicted in terms of 3 multi-valued discrete and 5 continuous attributes. So the MPG means miles per gallon. Now you will see I'm going to use this auto MPG dataset. There are 398 instances with 9 variables. So I can open the data table. So in this dataset, they already set the label or the target, which is MPG. MPG is the miles per gallon. So what does it mean by 18? It means the car will consume 18 miles per 1 gallon of the fuel. What about the other? 15. So it means the car can run 15 miles for every 1 gallon of fuel. And we can also have another kind of data. The car name is Chevrolet. And then the cylinder of the car is A. Displacement, I cannot explain well. This is the car components. Horsepower, so this is the car energy. Weight, it is the car weight. The acceleration, whether the car can move in the high speed as soon as possible or not. Model year, 70, and then the origin. The origin means where the car comes from. So the car's country. Now, using this data, you can look at the feature statistics. Okay, you can look this one. We have one missing value. So if you have missing value, means you need to perform some missing value handling. But yeah, I can show you later about this one. So if you look at this one, yeah, we have 7 features and 0.2% missing data. Let's say I just want directly to make the tree. Okay. So this is the tree. Can I just make the tree? So I will use the same parameters and then I will get this tree. So what does it mean by this tree? If you look at the data set, maybe I can just go to the select column. If you choose the select column, you will see that, oh, the MPG is out. Actually, the MPG is in the target. So the target is the MPG, which is numerical, and the remaining are features. Car name. Car name is only the car identifier. We don't need to do the analysis because every car is unique. But the other are the attributes that we can use to determine about the miles per gallon. If you look at the bias computer, when you select the column here, most of them are the categorical data, and the target is categorical. This is C, is categorical. Now, with this example, the target is numerical. Can we use this one? If we use this target with the numerical data, we call it regression tree, not classification tree. As you know, the prediction or regression, the target is numerical. So we have the regression tree, and then this is the tree. What does it mean by this tree? We know that the data contains of 398 instances. And we have 23.5. What does it mean? Can you guess? $23.5 means it is the mean of the MPG. 23.5. So from all the data, The average is 23.5 plus minus. So it means it is the variance. And the most important attribute is cylinders. Based on the cylinders, you can see that if the cylinder is 3, or the cylinder is 6, or the cylinder is 8, then it goes to the left. If the cylinder is 4, or if the cylinder is 5, then it goes to the right. Sorry, it goes to the left. Now you can see that if it is 3, 6, or 8 for the cylinders, the average is 17,3. This is the MPG. If the cylinder is 4 or 5, then the MPG is 29,3. It means if the cylinders, the attribute cylinder will determine whether the MPG will be low or high. So this MPG is 29 miles per gallon. This one is 17 miles per gallon. And then we can have another split, the displacement. If the displacement is less than 267, then it will give you the MPG 20. If it is higher than 267, the MPG average is 14.7, and so on. So we call this is the regression tree. The tree is based on the numerical value. If you have the regression tree, you can check the test and score. If you still remember in your exam, okay, in your exam there is one question. What is the performance measure if you are doing regression? What is the performance measure if you are doing classification? We are doing regression. Then the performance measure is MSE, RMSE, MAE, and R square. Do you know what is MSE? MSE is mean square error. Okay. We call error because we want to find closer to 0. Okay. If it is closer to 0, then it is the best. RMSE, it is root mean square error. The same with the MSE, it should be closer to 0. This is the best. What is MAE? It is mean absolute error. Closer to 0 is the best. The last one is R square. The R square means this is to see the correlation between the variables. It will give you the best R square if it is closer to 1. Okay, so if it is closer to 1, then that's the best one. So based on this information, let's see. The MSE 13. Oh, okay, it's quite high. The RMSE is 3,6. Okay, it's closer to 0. MAE, okay, it's closer to 0. R square is 0.7. Okay, it's closer to 1. Then this regression tree is quite good. you can make the comparison. Okay? Because in this class I didn't teach the linear regression, but basically you can use the linear regression to perform the numerical target. So I can check the linear regression, and then I can put it into this test score, and okay, the result is better. The linear regression, the MSE is smaller. The RMSE is also smaller. The MAE is also smaller. And the R square is higher. So whenever you do this kind of modeling, you need to compare with the existing or with the other algorithms. When I look at the regression tree and the linear regression, which one is better? Which one is better? The linear regression is better because the error is closer to zero than the regression tree. The regression tree, the error is still high. Then we can say that, okay, I will use linear regression as my model. We can do the classification. If you look at this data, okay, we have the regression tree. The regression tree means we have the target. The target is the continuous values. Okay, so here we have MPG is continuous. Cylinders is multi-value discrete. We know what is multi-value discrete? Discrete is the categorical data. Multi-value means there are several values, more than 2 values. Displacement is continuous, horsepower is continuous. Sorry. Weight is continuous, acceleration is continuous, model year, it is multi-value discrete, and origin is multi-value discrete, and the car name is a string. So the car name is unique for each instance, so you don't need to consider this one. We can create the regression tree. The first we already created. But now there's a question. Let's construct classification tree. What does it mean by classification tree? We know the classification is regression. We have the target, which is numerical data. The classification, we have the target as the categorical data. But questions. Our target here is MPG. MPG is numerical. Then how can we change the numerical into categorical? How can we change from numerical to categorical? There are several ways. You know, binning. Okay. When we do binning, we can split the data. Maybe if we create 3 bins, so in this you will have 3 categories. If you split into 2 bins, then you have 2 categories. We can use binning or we can use clustering. So we will learn more about clusterings. Or we can use just feature constructor. Okay. For now, let me just use feature constructor. Okay. In this feature constructor, I will use the split point, which is the average. The average is 23.515. So if the MPG is higher than 23.515, then it will be considered as high. Okay. If it is not, then it will be considered as low. So you can make this feature constructor and let's open it. So we have one more column, which is MPG cat is low. Why it is low? Because this MPG is lower than 23.515. Let's say this one is high. Why this is high? Because this one is higher than 23.515. Okay. So using this one, oops, sorry. So using this column, we can select the column and we can determine what is the proper features and what is the target. We want to make the classification tree. Therefore, the target should be the category. Here, the target is the MPG category. And because I put the MPG category as the target, I need to remove the MPG. Do you know why? Do you know why I need to remove this MPG? Because the MPG category is derived from MPG. So I cannot use this MPG into the features because it has a high correlation. You can check this one. Let's say I use this rank. Okay. If I include this MPG here, if I include the MPG and if you open the rank, there are some scoring methods. I think you already learned the information gain. You already learned the information gain ratio. You already learned the Gini decrease, Gini index, and you already learned the chi-square. So every of the measures are already applied in the audience. And you will see that the highest R square is MPG. Why? Because you generate this one. For every of this attribute, it will be checked with the low and high. So we will check how many low and high for this MPG. How many low and high for the weight? How many low and high for the cylinders? How many low and high for displacement and so on. And based on the calculation, the MPG gives the highest value. So the highest value in the chi-square, it means this is the most important. The highest information gain, the highest gain ratio, it means this is the most important. For this Gini, it is also the highest. Why we can say this is the highest? So some students give the answer on the exam. The attribute that provides the smallest Gini D will be chosen as the most important attribute. But some students use this reduction in impurity. It means we want to use the Gini D. The Gini D is the overall Gini minus the Gini in that particular attribute. So if we use this delta Gini, then we need to choose the largest reduction in impurity. The largest value when you reduce with the Gini index. So the delta, the highest delta or the largest delta will be chosen. That's why in this classification, this is the largest Gini because this is the delta. Okay. So if you see this one, this MPG is the highest one. This is the most highly correlated. So it should not be here. That's why we need to eliminate them. We cannot use this MPG. And this is the default parameter. We can get this three. And the final one, of course, we want to know the result. When we use the classification, the measure will be classification accuracy, M1 score, precision, and recall. So we want to check what is the best accuracy. So if you look at the orange, it's very simple. You don't need to type your code. So you can go to the model and you will select. You can see there are many algorithms here. So you can just select what is the proper algorithm. Let's say I want to use KNN. So you can just connect. Let's say I want to use the naive bias. So I can just connect. And then you can check. Okay, among those algorithms, CA, the highest CA is random forest. So my model, the best model is the random forest algorithm. Yeah, you don't need to code and you can get the model directly from this result. Yeah, for your team project, yeah, you will need to do like this one. You need to compare several algorithms in your data set, and then you need to explain if you get the tree, so what is the meaning by this tree? Okay, so please check my comments and please improve the proposal. Okay, and if you need any suggestion from me, just let me know.